I'm having difficulties with that camera. It's kind of not recording. Okay, so here we're interested in determining all these numbers. So what does this mean again? So let's look at the graph. I'm not graphing this function. I'm going to say it's s of t, but that's not it. I'm just graphing a function. So here is 0.1. So when x is 1, t equals 1, and here is t equals 2. So here's our graph. So this is the function s of t, and this is t, and this is s, and this is t equals 1 second, and this is t equals 2 seconds. Okay, now this 1 comma 2 will be the average rate of change between these 2 points. That's what that means, right? This is the interval. So we're going to determine that. What does the interval 1 comma 1.1 mean? Now this is 1.1. T equals 1.1. So now this interval will give us the slope of this secant line between points with x or t equals 1 and t equals 1.1. So that will be the second one. What will this one represent? India, will you tell us what that represents? What will this represent?
Sorry, I'm not sure.
Okay.
Isn't it just going to be an average that's just closer to the moment of 1?
Of course. So this is 1.1, so there will be a point here with the t value of 1.01. Very good. Thank you, Mark. What do you think the last one will represent? Let's say Sarah.
Wouldn't it be even closer?
Exactly. That's it. So you got the idea. So first, I want to determine this average rate of change. Then I will determine this average rate of change. Then I will determine this average rate of change. And closer I get, what am I really determining? The slope of the
Instantaneous rate of change?
Right, the slope of the tangent line or the instantaneous rate of change. Very good. Exactly. I'm not going to do this by hand 4 times. I highly recommend creating a function to plug in. Can anyone tell us what changes and what does not change in this problem? So the slope in general, right, is y2 minus y1 over over x2 minus x1. We know that. So we are trying to determine first y or s sub s2 minus s1 over 2 minus 1. Do you agree with that? S of 2 minus s of 1 over 2 minus 1. Is that okay, everyone?
Yes.
Okay, what will be the next one? S of 2 minus s of
1.1.
over 2 minus 1.1. What will be the next one? S of 2 minus s of
1.01.
Right. So in other words, this does not change and this does not change. It's always s of 2. It's always s of 1. So this doesn't change. S of 1 and 1 will not change. This will change. This changes. So we're going to create a function s of t minus s of 1 over t minus 1. Because s of 1 will not change and 1 will not change. S of t, I simply copy it. It's 2 sine pi t plus 3 cosine pi t minus S of 1. Let's analyze what happens when t is 1. Let's find S of 1. So how much is pi times 1?
Pi.
Good. How much is sine pi?
1 down to 0.
0. Very good. How much is cosine pi? Careful. Cosine pi.
0.
Negative 1.
-1 times 3.
Negative 3.
-3. Awesome. So this is +3 over t minus 1. Excellent. So now let's put this function in. Let me share my screen again. And where is my calculator? Sorry, guys, I have to move you again. Now, make sure that you go to second and plots and turn that off. Second and plot. Okay, I'll press enter and make sure you turn it off. Okay, so now go back to y equals, and in y equals, remember in parentheses because we are plugging in this ratio. We don't have t in the calculator, but we have x. So 2 sine pi x, close the parenthesis, plus 3 cosine, oops, I didn't mean that, pi x, close the parenthesis. So 2 sine pi t plus 3 cosine pi t plus 3, close the parenthesis, and now divide in parentheses x minus 1. What if I plug in 1 in this function with second and table? Make sure in table set, make sure you have this, second and table set. Make sure the independent variable is in the ask mode. Only the independent, not the dependent. So we go to second and table. And I would like to plug in 0 in this 1 in this function. What do you think I'm going to get? Of course, y. I don't know why this is still there. It shouldn't be. It should go away. Okay, it's not. It's wrong. So why, when I plug in 1, why do I get an error?
Because if you put a 1 in it, there's going to be a 0 in the denominator.
Of
You
course.
divide the function by 0.
Of course. Of course. Okay, so now what numbers do I need to plug in?
Numbers close to 1.
Excellent. Can you dictate those? So first of all, we start with 2 because we are asked to find the average rate of change between 1 and 2. Can anyone give us the average rate of change between 1 and 2? Can anyone read it?
Is it just the 6?
Measurement unit?
Oh, what was the problem again?
Seconds?
It has to be a ratio. We are talking about the average rate of change. Please do not give me one measurement unit without the other.
Centimeters per second.
Centimeters per second. Very good. What is the next number that I have to plug in to get the average rate of change?
1.1.
Excellent. 1.1. Can anyone give us or tell us what this is?
Negative 4.712 centimeters per second.
Very good. Which means it's decreasing. That's all it means. Okay, what is the next number I have to plug in?
1.01.
Great job. And then 1.001. And I don't trust all this, and I'm doing this. I want to be as close as possible. So I will create a table, and you'll see it in a moment, with t and the slope. So it will have under 2, will have 6. One point 1, 1.01, 1.001. And I'm copying 6, I'm copying negative 4.7, negative 6.134, I'm copying negative 6.268, and negative 6.28. I stop sharing right now so you can see what I wrote. Okay, so the average rate of change between 2 and 1 is 6. The average rate of change between 1 and 1.1 is negative 4.7. The average rate of change between points with 1 for x or t and x or t 1.01 is this. Getting closer now, between 1 and 1.01, I get this slope. And this is the instantaneous rate of change, also called instantaneous velocity. As long as the function is a distance, this is not only the instantaneous rate of change, but also the velocity, the instantaneous velocity at that point. You could say, I don't want to do this. I want to do this. That's fine. You just write them step by step. You're going to write the same thing 4 times, but I don't recommend it. I recommended creating this function, putting the graphing calculator and getting all the numbers at once. Of course, it's up to you. If you want to repeat the process 4 times, you can. I didn't even trust this. I really wanted to be even closer. So I shouldn't really put 1. I should put 1.000000001, and that is the best estimate possible. Because I was so close that it will look like P and Q are overlapping. They're not the same. So this is not P and Q. No. Q is here, and Q gets very, very close to it without overlapping it. Okay? So this is indeed. And the measurement unit for all of them, centimeters per second. It's a rate of change. Remember, it has 2 measurement units, one coming from the top and one coming from the bottom.
I have a question.
Please.
So go back up above the table. Why did you have to add the +3 there?
We determined that S of 1 was -3 with minus in front. It changes into +3. This is this. This is this. This is this. This is this. That's why we determined it here, so I don't have to write it again. So even this, and this is in centimeters, because it's the distance.
Thank you for explaining that.
Of course, anytime. Is this okay? Good.
Yes.
I think we got the picture. Okay, let me ask Leo or Leonardo, are you okay with this?
Yes, I'm okay.
Okay, Carson,
Yes, thank you.
Javon,
Yeah.
Ian.
Yes.
Okay, please tell me, because we need to move on. So 2.2, the limit of a function. Okay. So first I would like to talk about the concept of an operator. What is an operator? Anything that we can apply to a function or to an expression or to a variable. What is an operator? Square root. Square root is an operator. Natural log is an operator. The cube root is an operator. Well, we're going to talk about a new operator called the limit. And the limit is denoted by LIM, and is a limit, an operator that is applied to a function. And now we have to explain or mention what happens to x. So when x approaches a. And what's all this and what is it useful for in a minute. But first, let's talk about the notation. So the limit, lim, is the limit. It's an operator. It's applied to a function. And this says, or represents, or it's read, when x approaches a from either side. When x approaches a number, a is a number, from either side. The word approaches automatically means x does not equal a. When we say approaches, we mean approaches, gets closer and closer and closer, but it does not equal a. Again, how do we read this? Limit of f of x when x approaches a from either side. The limit of f of x when x approaches a from either side. Okay. Now let's take a look at a few things here. So page 5. So here's a function again. This is f of x, and this is a, and this is, of course, f of a. And as you see, if x approaches a from this side, or x approaches a from this side, it doesn't matter. The function values from either from this side decreasing or from this side increasing, the way I graph the function, will approach this number in this case. And it happens that this is also denoted by L. This is a very simple function. It's a polynomial function I chose to illustrate this. And we say that the limit of f of x as x approaches a from either side is L. L must be a number for the limit to exist. If you say L is infinity, I will say sorry, then the limit does not exist.